Assalamualaikum and a very good morning to everyone. My name is Nur Emiliani binti Muhammad Kamaruzzaman and I am currently a student from the Faculty of Agro-Based Industry, University, Malaysia, Kelantan. Today, I will present the summary of my industrial training which I undertook as a part of the FST 40208 course. My internship was conducted under Dr. S. Karthikeyan as my industry supervisor and Dr. Zuhalida as my academic advisor. This training has given me valuable exposure to real-world industry practice and has enhanced both my technical and professional skills. Throughout this presentation, I will be sharing the activities, challenge, outcome, and personal reflection on my internship journey. I hope this presentation will provide you with clear insight into my learning experience and how it has prepared me for future career opportunities.
That only prove, and this is when
I would like to express my sincere gratitude to Vignan University for providing me the opportunity to undertake my internship and gain valuable practical experience in a stimulating academic and research environment. I am deeply thankful for my supervisor, Dr. S. Karthikeyan and Ms. Agila Dashwari as PhD scholar for their constant guidance, insightful feedback and encouragement throughout the internship. Their expertise and support were instrumental in enhancing my understanding of the subject and developing my skill. I would also like to thank the faculty members and fellow interns to their cooperation, knowledge sharing and warm support during my time at the university. The facilities and resources made available significantly contribute to the success of my work. Lastly, I extend my heartfelt appreciation to my family and friends for their continuous motivation and support during this journey. The journey of Vignan began in 1997, a landmark year that witnessed the establishment of Vignan Engineering College, the first campus at Vadlamudi. Founded under the visionary leadership of the Vignan Educational Trust and brought to life by Dr. Lavu Rataya, a pioneer in progressive education. Vignan was built on the foundation of academic excellence and societal responsibility. Driven by its mission to provide high-quality education through innovation, ethics, and holistic development, Vignan aims to nurture competent professionals with strong values, guided by a powerful vision to be a global leader in education, research, and innovation. Vignan continues to inspire students to reach beyond boundaries and shape a better future. For the organization background, the institute has been awarded full accreditation after evaluating in IAO standard of the global best practice in organizational management, academic management, and institutional performance. IAO full accreditation is a proof that Vignan Foundation for Science, Technology, and Research offer education to its students that is on par with global education standard, and that the institute is fully committed towards continuous improvement of its educational standards. This is the organization chart of Vignan University, followed by Dr. Lavu Rataya as the founder and chancellor, Meanwhile, Professor Dr. Nagabhushan as the Vice Chancellor, followed by all the decan and HOD of every department, which my department is Food Technology, and lastly followed by Coordinator of Faculty. For my summary of daily activity, in week 5, I was introduced to laboratory routine involving plant tissue culture and nutrient media preparation. I learned how to handle lab equipment like the autoclave, laminar flow hood, and pH meter with precision. This foundation was crucial as it trained me to maintain sterile conditions and understand the principle of plant growth in controlled environment. For my week 6, my task expanded to include the germination of seed in the test tube with nutrient agar. This process required careful handling and observation of plant responses. I gained practical knowledge about plant physiology, particularly how different nutrient composition affect germination rate. It has improved my patience and attention to detail, both critical traits in scientific experimentation. For my week 7, I engaged in preparing various concentration of nutrient solution and learning how pH and temperature can impact microgreen development. I also recorded the humidity and temperature, which helped me understood how environmental conditions directly influence growth outcomes. This week reinforced the importance of data logging and environmental monitoring in plant-based research. For my week 8, I involved field observation and the early stage of microgreen development, such as cotyledon formation and the appearance of true leaf. I learned to differentiate this stage, which enhanced my understanding of plant growth cycles. This experience deepened my appreciation for morphological development and its implication for harvesting microgreen at optimal nutrition value. Next, in week 9, I was involved in the application of nutrient sprays and observed their effects on different microgreen types. I also started learning about juice extraction from various microgreen and combining them with fruits. This creative yet scientific aspect of the internship taught me the importance of product development and the potential for creating health-promoting beverage. For week 10, I was particularly challenging yet rewarding. I faced issues with agar not solidifying, prompting a deeper investigation into formulating error. I learned troubleshooting skill and gained confidence in modifying standard protocol to suit experimental needs. Collaborating with lab partners improved my communication and teamwork abilities. For week 11, I conducted acidity testing and titration on fruit-based sample. This analytical technique helped me appreciate the chemical properties of food and their role in product stability and flavor. I understood how to interpret results and the importance of accuracy in food quality testing. In week 12, I explored advanced topics such as FTIR and SRT analysis related to microgreens. I learned that these tools could reveal molecular structure and crystallinity of nutrition, essential knowledge for developing functional food products. Though I was not directly involved in operating the machine, the exposure to such techniques broadened my view of scientific analysis. Last, for week 13, I prepared for the completion of my internship. I compile my data, reflect on my progress, and appreciate how far I had come, from someone unsure about laboratory procedure to someone capable of conducting and understanding scientific experiment. This week was a moment of pride and closure as I could connect the dots between classroom theory and practical application. For Chapter 3, project that I had done is development of an edible sheet from using natural functional ingredients. The aim of this project is to create a product that is not only healthy and nutritious but also environmentally sustainable. We focus on optimizing the structure, nutrition, and texture of the edible sheet to make it both functional and appealing. The objective of the This project is to develop an edible sheet using seaweed as the main base, blended with other functional ingredients. And second, to improve the texture, flexibility, and nutritional value by experimenting with different binding agents such as tapioca starch, gum, and collagen. The process began by mixing all the dry ingredients together. Warm water was then slowly added while stirring to form a smooth mixture. Glycerin and collagen were added while heating the mixture to around 60 to 70 degrees Celsius to help dissolve and activate the ingredient. The mixture was then homogenized to ensure uniformity and poured into tray for shaping. Finally, it was dried in a hot air oven at 50 to 60 degrees for 8 to 12 hours to create the final edible sheet. In conclusion, through this project, I gained valuable hands-on experience in food formulating and learned how different ingredients contribute to the texture, structure, and nutrition value of a product. I also discovered the potential of seaweed-based sheet as a healthy, eco-friendly snack alternative. This project has inspired me to further explore natural, innovative food solutions in the future. Next project that I had done is fruit bar. This project detailed the formulation and development of a functional fruit bar incorporating mango sweetener and microgreen extract. The goal was to create a nutrient-dense, naturally sweetened fruit bar that delivers both taste and health benefits. The objective is to formulate a functional fruit bar using natural ingredients and to enhance nutritional value through microgreen extract. The procedure is extract microgreen using cold blending and filtration, mix mango and sweetener to form a uniform fruit base, and incorporate microgreen extract gradually into the mixture. Add pectin as optional for structure and lemon juice for natural preservation. Heat the mixture gently at 70 to 80 degrees to reduce moisture. Spread mixture evenly on a lined tray and dry in a hot air oven at 50 to 60 degrees for 24 hours. Cut into bar shape and package in airtight wraps. Conclusion: The developed fruit bar was a successful combination of natural sweetener and microgreen functional ingredients. It offers a healthy alternative to processed snack. The inclusion of microgreens contributes positively to the antioxidant properties but should be balanced to avoid strong bitterness. Chapter 4: Conclusion. This is my conclusion of LinkedIn screenshot. For Chapter 5, Suggestion for Faculty Industrial Training Program. 1 is include more hands-on industrial exposure, organize regular visit to food processing industries such as juice, dairy, packaging plant, so students can observe large-scale operation and GMP and automation technology directly. Second, incorporate real product development project, which is allow students to participate in live R&D projects such as formulating functional food and beverage using microgreens, which improve innovation and understanding of market trends. For 5.2, Suggestion for Industry. First is provide students with a mini project or case study, which is industry can assign students a small but meaningful task such as quality testing, shelf life analysis, or cost optimization to build problem-solving skill and give a sense of responsibility. Second, host industry mentorship session. Regular guidance from experienced professionals such as QA manager or R&D heads that can enhance student confidence, career direction, and bridge the gap between academic learning and real-world challenge. Last but not least, suggestion for myself is I need to improve technical skills and lab techniques, which is focus on mastering techniques like TPC, TFC, antioxidant assays, and FTIR so I can independently handle analysis and understand their application in product development. Second, develop deeper knowledge of food regulation and standard, which is I can take the initiative to learn about food safety standards such as FSSAI, MSTI, halal and labeling regulation. This will help ensure that any product I develop meets legal and market requirements, especially if aiming to commercialize functional food like microgreens juice.